It's really my pleasure to introduce to you some of our interim findings on what we've been exploring on how to classify AI systems, particularly with an eye of making it relevant and useful for policymakers. As was already talked about, I'm part of the One AI group of experts, and it's been an incredibly fruitful discussion that produced the work that you're going to hear a little bit about now. So why classify AI systems? AI systems are pervasive. You've already heard about some of the COVID-19 and health-related implications of AI systems. You also can imagine AI systems controlling water treatment plants and releasing how much chemicals are released. You know about self-driving vehicles, or the AI is helping control the steering, the braking, the acceleration, the navigation. You might see AI on a manufacturing production line where AI is using videos and other sensors to recommend predictive maintenance on the production line. Or in children's videos, an AI system might make recommendations for what your children might watch next. Each of these AI systems works in different contexts and has very different policy considerations. So when we figure out what are the key elements, and you'll see this in just a second, what the key elements are that we believe should be considered when doing policymaking or doing regulation. So consider, a lot of the times we understand the impact of AI systems through the events that they cause. And some of these are unfortunate events. So an autonomous car might, you've heard about an accidentally killing a pedestrian, or a trading algorithm being instrumental in a flash crash, or facial recognition system causing an innocent person to be arrested, or just the fundamental data issues in collection of data. Is it representative? Is it something we can rely on? Is it going to impact system performance? All of these factors are truly instrumental in understanding how the AI system interacts with society. And as we think about regulating it, this situational awareness is critical. So when we look at these instances, we can understand how regulators or policymakers can help understand where to focus their efforts, where the core element of data governance is that would actually impact performance. What are the kinds of things that need to be watched or evaluated? And so this is what we're going to talk about, how to look at the particular AI systems. So as I mentioned, our goal was to create a user-friendly framework to navigate the policy implications of different types of AI systems. We had 4 basic dimensions in this, and I've color-coded them throughout the talk. Sorry, the colors are a little garish, but it's important for us to remember them. First of all, context. What are the systems, where are the systems designed to operate, and in what regulatory context? For example, healthcare has a very different regulatory context than manufacturing or finance or entertainment. Secondly, the data and input that's required to fuel these AI systems. Thirdly, what basic types of algorithms and models truly make the AI systems work. And then the fourth one, what tasks do they execute and what is their output? If we think about AI systems through these 4 lenses, or 4 dimensions, we can now start to break down even further what elements we need to consider when we're reviewing a particular AI system or thinking about where policymaking effort should be focused. So once again, keeping with the same 4 dimensions, let's start to break down a little bit more what are key elements of this classification. I've selected a few examples for each of these colors just to be illustrative and to help differentiate between AI systems. So in the context space, what is the sector in which the system is operating within? We've used the International Standard Industrial Classification of all economic activities standard for being able to select what the particular sector is. So transportation and storage would be self-driving vehicles. Water supply, sewage, waste management, and remediation activities would be wastewater treatment for optimizing chemical treatment and the like. Manufacturing would be not surprisingly, manufacturing. Health and human, human health and social work activities would where you see a lot of the medical implications. So that's the first one. Now, understanding that once you've identified what sector you're in, there's a lot of other regulatory elements that immediately come to mind because you understand what context it's working in. Now, it's worth noting that just because you're in the healthcare sector, that not every healthcare system is of critical importance. One might be just tracking the time or staffing in a hospital, and that's probably not as critical as the delivery of healthcare in an emergency crisis, for example. Okay, so that's exactly the second point, this critical function. Is this a critical function or not? The next one, what are the system users? Are they AI experts or are they not AI experts? As we start to break down into the data and input, was this data collected by humans? Was it an automated system that collected this data? Was it the system's experience itself that collected the data and helped it operate? These are really important dimensions. Also, the data domain, is it proprietary data? Is it public data? And then there's personal characteristics of the data that would be also part of this. Now moving to the third one, the AI model, there's a lot of things that can be considered about the AI models. I'm highlighting one of them, which is the acquisition of capabilities. Is it learning from people? Is it learning from the data that was provided it? Is it learning, once again, from system experience? These are really important, and we'll get into a couple examples and why this is a relevant characteristic. Thirdly, or lastly, I should say, the task and output is another really important characteristic to understand. Is this task that's being executed, is it recognition, identifying or classifying data? Is it event detection? Is it forecasting? Is it a personalization effort that's trying to develop a profile of individual behavior and learning to adapt the output over time to that personal behavior? Is it interaction support where it's trying to provide an interface between human and computer interaction? Is it a goal-driven optimization system that's truly focused on just trying to achieve the simple goal that, or maybe even complex goal that it was received? Or is it reasoning with knowledge structures? This is a really important characteristics that would once again determine how we think about regulation. And then, as was already mentioned in the introduction, level of autonomy. Is this a high action autonomy? Is it one that a human is out of the loop and the computer can just execute based on as part of normal operation without human involvement? Is it kind of a medium action autonomy, which is often referred to as human on the loop, where you have normal operations, the system has limited capacity to self-govern and requires human involvement to perform designated tasks? Or is it low action autonomy, where the human is in the loop and the normal operation of the system, human involvement is necessary to overcome uncertainty or provide an ultimate decision-making authority? Or is it even a fourth category, is it just human support? It's basically just informing me and I have to do everything as a human in the system. So these are just some of the factors to consider. Let me just give a couple examples to try to drive this home. So AlphaGo Zero is a games example. This is from DeepMind. What they did is they created a system that was this is well known, so I'm sure you've all heard about this, of a system that learned how to play chess and other games, or Go, obviously is in the name as is in the name. Can they win games? And there's no human data here. It just played against itself. The self-play was the key part. So is it a critical function? No. The system users were AI experts in the original deployment. The data collection was all automated in the sense that it was creating the data itself, and this was proprietary. It wasn't something that was out publicly available elsewhere. It learned from its system experience, and it had a goal-driven optimization system. And this is really important for this type of AI system. Without a really clear definition of goal, like winning the game, this system doesn't operate well. And it was a high level of action autonomy. The human is out of the loop, computer did everything. Now let's look at GPT-3. This is a text generation system that allows in information communication. It generates text, once again, a well-known one from OpenAI. Primary users here are non-AI experts. It's the data that was drive this is all the humanly available data that it could get its hands on of text. And this was largely in the public sector. the capabilities were very much driven by the data. And the interesting thing about GPT-3 and its predecessor GPT-2 is the amount of data and this number of parameters in the model really determined its performance. So the more data, the better in this case. It's once again a goal-driven optimization in terms of writing, but it's very much focused on interaction support. Is it creating content to power the human-machine interaction through that text? Now, the autonomy is a really interesting question here, kind of a medium level of autonomy, because the human is required to execute and use this text that's generated currently. There might be instances where you could eventually see a system automatically generating this text and distributing it without a human interaction. But right now, humans are the mediators of this. So now you've just seen two AI systems. Let me bring one more in to round it out, and then we'll close. So credit scoring AI system is another one. So this is in the financial insurance activities. This is a critical function activity. It's a core service, economic service. The system users are primarily non-AI experts again. Human and automated sources are used to inform the credit score of individuals based on their interaction, their how they've paid bills and all that kind of stuff. And then the data domain, it's a mix of proprietary and public data. This is actually somewhat of a complication because you actually, not all this data is available publicly, which is reasonable because it's personally identifiable. But this is what's driving this credit score for individuals. It's learning from provided data. And it's learning in aggregate. So it's basically saying, I don't know as much about you, but people like you have had this kind of issues with their credit score, their loans, therefore loan repayment, therefore it's imputing that upon you. It's doing forecasting essentially because it's predicting future outcomes based on through a credit score number and ultimately in informing underwriting of loans. And the level of autonomy is medium. So the human is supposed to be in the loop, but you know that the speed in which these systems operate, sometimes it might actually be in principle a much higher level of autonomy in terms of executing for an individual loan decision. So you've just seen three different systems as examples of how these this AI system categorization could work. Hopefully it's given you a sense of why it would be useful to your policymaking context that you're thinking about and why this framework is particularly helpful. The next steps, we are going to test this framework, continue to test it with human users and refine it over the next few months, populate it with more AI system examples, and then publish an updated version early 2021. I just wanted to say, tip my hat as I closed. Thank you so much to the 57 experts from 40 countries who made this possible, and our co-chairs helped, and the secretariat was amazing to make this actually possible. Thank you so much.